Guys, this is the smart changeover with fuel monitoring system. You can see I have two inputs. This one is a power supply for the system, and the other one is a 12 volts input supply, which has been stepped down using a back converter, which I'm using as my KPLC input. Now, as you can see, we have the valve, which is the one that is actuating the generator fuel pump, and this one is acting as a generator. I'm using LEDs for further demonstration, but it's a real project. Then I have a sensor, ultrasonic sensor, which is used to measure the fuel level. Then I'm switching on the power supply. These are 5 volts power supply. My projector is using 5 volts. As you can see, it is connecting to the IoT cloud. And then you can see immediately, because the KPLC is not turned on, it automatically shows the running time of the generator and shows generator is running, and then the counter of the generator runtime. So you can see in my phone I have an application whereby you can see the fuel level remotely. You can see the runtime of the generator, and two LEDs, one for showing the fuel valve is on and the other for generator is on run mode. You can view it in a remote mode wherever you are in the world. As you can see, when I press my hand in front of the ultrasonic sensor, the fuel level in my phone is changing as well on the LCD display. So that shows, that tells you it is a real-time monitoring system. Then when I switch on the KPLC power or the grid power, you'll notice the change both in my phone and in my LCD display. Wait and see. The LCD will display the KPLC is running, switches off the generator, the runtime will stop. As you can see in my phone, the fuel level, the previous, and then still you can see in my phone the condition is the generator is running with an LED, blue LED on. So when I switch off the KPLC power, it will stop, and then the counter will resume from the initial position, and the LEDs for the valve and the generator, you can see automatically goes on, and this time can be even